Example 4.3.3, find the ampacity for each of 5 current carrying number 4 AWG RHW copper conductors in an ambient temperature of 50 degrees Celsius. So what we have here is a derating problem. Conductors are rated if they're in a raceway or if by themselves, meaning there's no other conductors around them. And they're also rated typically at a standard temperature of 20 degrees Celsius. So the ratings for how much current they can carry are provided. There's one wire only, and it's at the ambient room temperature is 20 degrees C. And so we're being asked, okay, well, how much current is reasonable to put through this conductor if instead of just one, there's 5 of them in a single raceway. A raceway just being something in which all the wires are housed together. And then also the ambient temperature isn't 20 degrees Celsius, it's 50 degrees Celsius. And we're looking at a number 4 American wire gauge RHW. The names of wires, especially low current wires below a couple hundred amps, are usually given by these acronyms. You'll learn them eventually if you work with them. RHW talks about it's a rubberized, heat resistant, and water resistant cable. That's what RHW stands for, rubber, heat, water. So anyway, we need to derate this RHW cable, which means derating should imply to you that we're going to decrease the amount of current that is safe to run through it. So we start with this NEC's ampacity table that I gave to you in the text. What we need to do is find the conductor on the table based on its size and temperature. Its size and type. So what we can see is that we need to go to the wire size first. So there's a 4 right there, that's 4 American wire gauge, and then we need to look for the metal that it's made out of. So we're in copper. That puts us in the left half of the table. And then we need to find the type. So we're looking for that acronym RHW. You see it right there. So we find the cross section of those two, and that puts us at 85. So the cable is rated at 85 amps. So that's how much current it can normally carry. But we have to derate it for the two facts that it's we're going to be using multiple wires and that it's going to be operating in a 50 degrees Celsius environment. So derating factors for multiple conductors, I gave you a table for that in the text as well. That's just done by the number of conductors that are run together. This example said 5, so we come over to the table and we find that the derating factor for between 4 and 6 conductors is just 0.8. So the new current is going to be the rated current, 85 amps, times 0.8. So that takes care of the multiple conductors in a single raceway. We can only run 80% of the current through it. Now we got to derate it for the temperature of operation. So this is a 75 degree cable. That's this right here. The ambient temperature it's going to be run in is 50 degrees, so that's this right here. We find the intersection of those two, so the derating factor for operating in this temperature environment is 0.75. So we have to multiply those together since they're basically telling you what fractional percentage of the current you can run through that. So that just gives you 51 amps. So if we're going to run 5 of these and the ambient temperature is 50 degrees C, the most we can put through any individual cable is 51 amps.